Everyone. I hope you can hear me. My name is Sue Page. Thank you for joining us this morning, or should I say this evening, for our many guests joining us online from India. Thank you for taking part so late in your day for our third workshop on regenerative agriculture and the important role that the digital technologies can play in fostering sustainable agriculture. This topic is important to both our Supercluster organization and to member companies like Terramera, as we all see the potential of regenerative agriculture for the future of our agriculture sector and for building a prosperous and sustainable future for our families and our communities. It's an honor to be hosting these events with our partners, the Asia Pacific Foundation and IITM-Pravartak Technologies Foundation in India. I'm joining you from my home in North Vancouver, where I'm grateful to live, work, and raise my family on the traditional and ancestral territory of the Indigenous Coast Salish peoples, the Musqueam, the Tsleil-Waututh, and the Squamish. I also want to take this opportunity to tell you a little bit about our Supercluster team and our purpose. 2.5 years ago, we had an ambition to solve some of industry and society's biggest challenges through the development, deployment, and scaling of Canadian-made digital technologies, and through this to accelerate the growth of Canadian small and medium enterprises, create partnerships across organizations of every size and in multiple sectors, and to put Canada on the map as a global leader in digital solutions. Today, I'm pleased to say that our small and mighty team based here in Vancouver is working with over 800 organizations from all across Canada in sectors ranging from mining to healthcare, quantum computing to software development, to post-secondary education, supercomputing, forestry, and of course, agriculture. Our impact goes beyond jobs and investment dollars. The projects that we are supporting are improving the way of life for Canadians and helping to advance our country to build a promising and prosperous future for Canada. And yes, planning for that even as all of us continue to navigate the uncertainty of our global pandemic. One thing we know for sure is that partnerships such as the ones between our two countries will be good for all of us. And it's such partnerships as the ones being fostered through these workshops that provide the inspiration and the foundation for that promising future. Over the past 2 workshops, we've seen some incredible examples of how agriculture and technology are intersecting in ways that will allow for greater sustainability. And I certainly look forward to what will come from the discussions and the collaborations that are starting now and will continue into the future. Events and opportunities such as these do not happen without foresight, determination, drive, and commitment of very special leaders. And we have some of them here today. Sorry, I've just lost my sound there. That didn't work. First of all, I would like to acknowledge my colleague and dear friend and leader in our technology community, Bill Tam. It's Bill's determination, his foresight, he's the engine that has really driven our organization's excitement and involvement in this opportunity. He's the co-founder of our Supercluster, and he's one of the reasons we're all here today and have been over the past 2 workshops. Thank you, Bill. One of our co-hosts is Stuart Beck, the president and CEO of the Asia Pacific Foundation. Prior to joining the Asia Pacific Foundation, Stuart served as the Canadian High Commissioner to the Republic of India. He's also held exemplary diplomatic and public service positions across multiple portfolios, and in a decades-long commitment to Canada, Stuart has really made our country better. Thank you, Stuart. It's an honor and a pleasure to work with you. And our other co-host is Dr. Kamakoti, Professor of Computer Science and Engineering at IIT Madras. He's a member of the Prime Minister's National Security Advisory Board and chairman of the Government of India's Artificial Intelligence Task Force. Dr. Kamakoti is dedicated to building collaboration between our countries in artificial intelligence, machine learning, and digital innovation. So much so, he's the principal organizer for India's participation in this workshop. Kamakoti, we wouldn't be here without you. So Kamakoti, I'm going to turn the microphone over to you to say a few words. Thank you very much.
Thank you very much, Sue. And it has been a wonderful set of 2 events that we have witnessed in the last 2 weeks. And I'm sure today we have the most important topic of data in agriculture and how we go forward. And I'm very thankful to Mr. Beck, who has who had actually come over to Delhi and started in a meeting there at the National Security Council. And this has come to this stage along with the Digital Supercluster. And I thank Mr. Beck for taking this initiative. And of course, great support from Mr. Bill over the last 1 month or 1.5 months to bring this event to this level. And I think we have covered a large variety of topic and breadth of topic in the area of precision agriculture. And today we have we call it the Data Day, right? This event is actually hosted by IITM-Pravartak Foundation Technologies. This is a not-for-profit foundation funded by the Department of Science and Technology, Government of India, specifically to nurture and promote translational research in the area of cyber physical systems. I'm very thankful to my director, Professor Bhaskar Ramurthy, who is also the chairman of the board of governors of Pravartak, IITM-Pravartak Foundation, who has joined us today. Professor Bhaskar Ramurthy is the lead in the India 5G testbed project. It is a very, very important today, even in the context of precision agriculture. He is a professor of electrical engineering, and he also is an alumnus of IIT Madras. His area of specialization include wireless communication and communication technologies. I now invite Professor Bhaskar to give his address. Thank you.
Thank you, Kamakoti, and a very good morning and a very good evening to all those who are who have joined with us today for this online virtual meeting. I'm honored to be part of this gathering today. I've also noticed that this is the third leg of the workshop. Two others have already gone before this, and Kamakoti has told me that it has worked out very well, that we see an enormous potential for collaborative work between the Digital Supercluster in Canada and the various groups in India which are focused on the kinds of technologies that the Digital Supercluster is focused on. But today we're particularly looking at agriculture, and particularly in the context of cyber physical technologies, sensors, data analytics, and so on. And in that context, I would like to share my perspective very briefly. It is customary to focus on increasing yields when one talks about agriculture, particularly in a country like India, where if you look at the published data on yields, they are quite low compared to the yields that you can get from highly controlled and mechanized farming elsewhere in the world. However, there are now, various other concepts of defining productivity, and finally, the farmers are in the business of farming, and they have to measure finally from the point of view of the profits they make. From a national and international point of view, we are concerned about whether there's enough food for everybody, and there are many projections that project that we need to grow a lot more food, but globally. But if you just take India, which is large, of course. As a country by itself, we grow more than enough food than we need, and it doesn't look like that is going to be a big, showbuster, because even if the population increases as projected by another 15–20%, I think that much increase in food is not a difficult thing to do. In other parts of the world, the situation might be different, but I'm not going to focus on that. Given that that is the case, we have a very large fraction of our population engaged in farming with very low per capita income. The traditional model world over has been for people to exit farming in large numbers. Finally, a very small segment of the population continues to do farming at huge scale, and the farm produce is a commodity that you grow in enormous volumes with very low margins, and its productivity that gives you the income. My suspicion is that that model, though it's tried and tested in many parts of the world, may not quite work out in India. If I don't know if other parts of the economy can absorb everybody but 2% of the people. And there are many issues related to the way the farm holdings are, in India and so on, without getting into further details. However, there is another tack one can take on this, and that is intimately connected with the potential of precision agriculture and digital, I would say digital agriculture. And that is, the value addition of the farmer and the farm produce can come from the customization of what, and the specialization of what the farmer is growing. People are as people earn more in other walks of life and other vocations, they do want to spend more on quality inputs of whatever, including food, and differentiation of the food, moving away from commodity to something that's differentiated in terms of how it's grown, in terms of what it contains, in terms of the sustainability of the whole process, in terms of the, even very fine nuanced differences in taste and quality and so on. So the ability of farmers to actually increase value for what they are growing by differentiating their products rather than commoditizing them, and selling to very specialized markets, highly sophisticated markets, selling their produce to interest groups that are keen to buy what they want. India has probably thousands of varieties of rice, for example, rather than just treat it all as rice, which is what we do today. Traditionally we were not that way. People knew many differences between many types of rice, and knew how to what to use for what, and cared about it. So we could go, we could go that way, and that can yield enormous income to farmers, and with probably a smaller number. I mean, definitely the number of people in farming will have to go down, but not to the kind of levels prevalent in the advanced economies. And still, I think it may yield very good standard of living and income levels to farmers if we go this route. Now, to do this, you need a lot of precision, because you're talking about precise qualification, precise measurements, guarantees to customers that yes, indeed, this product has been grown the way it has been claimed, has been, has the qualities that it claims it has, and so on. So a lot of sensing, measurements, certification, verifiability, and supply chains. Because if you're going to supply decommoditized farm products in their thousands or in their tens of thousands to customer interest groups, you need an enormously sophisticated supply chain for that. So, but then modern e-commerce and modern supply chains can definitely, which are heavily based on digital technologies, can definitely enable that. So I feel that we should really, and this is what one of the things that we want to do in Pravartak, is actually to look at these things, everything from sensing to measurements, to guarantees of quality, guarantees of the characteristics that are claimed for the product. If it's organic, guarantees that it's organic. If it claims that it's grown in a certain sustainable way, then guarantees of that, and so on and so forth. And then the supply chains to take products which may not be, which may be grown in fairly large quantities, but not in the kind of, millions of tons in an undifferentiated fashion. But take these to the customers who are interested in them in different corners of the country or indeed the world, and establish those very efficient supply chains. So all of this, as you can see, is going to be based on digital. So the digital farmer is the way I see as one of the important ways of the future, and the digital consumer who's already there. So this is really one of the slightly differentiated way in which we are looking at it, in addition to, of course, the traditional ways of, improving the precision of farming, improving yields, improving productivity, and so on and so forth. So just with that one major point that I wanted to make through my comments, I would like to conclude what I wanted to say and wish this workshop the rest of the day, all success. And I hope all the people who are going to participate are going to learn a lot from each other and make new connections, and more importantly, discover new avenues for collaboration and new avenues for thinking. I hope that what I've said may help some people to start thinking on some new directions. And hopefully, I'm sure you know, there may be a lot of holes in what I said. And that's the job of research, to discover them and plug them and find new ways of doing things. So I wish all the people who are participating in this all the best. And I look forward to great collaboration between Canadian entities, Canadian researchers, Canadian innovators, and Indian entities, researchers and innovators, particularly those at IIT Madras and those who are working as part of the cyber physical systems mission of IIT Madras, which is sort of captured in the Pravartak Foundation effort. Thank you very much.
Thank you very much, Professor. And those were just perfectly attuned to the themes that we have today and many of the discussions that we've had in the workshops up until now. Good morning, everyone. My name is Bill Tam, and I have the honor and privilege of working with Supesh as one of the co-founders of the Digital Technology Supercluster, and to really codify all of the work efforts that Professor Kamakoti, Mr. Stuart Beck, and the Digital Supercluster have been embarking on for the last several months. We now have the opportunity now to solidify that in a memorandum of understanding that we will now proceed with. And without further ado, Sue is going to start the process. We're going to do all of this digitally. It will be a digital signing of an MOU that will cross the Pacific Ocean, many time zones, and really solidify what we have seen the last several workshops and what we look forward to as a true collaboration on many levels between Canadian organizations and Indian organizations. So Sue, without further ado, if you would begin the MOU signing process on your end. And congratulations, everyone. Professor Kamakoti, I'll hand the reins to you now, and we can begin the keynote portion of our event today.
Thank you, Mr. Bill. And the first keynote today is Harnessing the Power of Sky and Earth. And this will be presented by the Tata Consultancy Service team, headed by Dr. K. Ananthakrishnan. He is the Executive Vice President and the Chief Technology Officer of Tata Consultancy Services. So Anant directs research, innovation, and co-innovation in TCS. TCS has created a significant range of new products and services with a wide IP portfolio under its leadership. And Anant has served on several governing councils of academia, industry advisory boards, and government and alumni committees. He is a fellow of the Indian National Academy of Engineering, and he is also a distinguished alumnus of IIT Delhi. We also have Dr. Sini Papula. He's the Chief Scientist and Global Head, Tata Consultancy Service. He is responsible for driving the usage of information and communication technologies for improving farmer livelihoods across the world. His ambition is to create technology-powered avatars of the Gandhian Gram Swarajya, thereby fostering village-level self-sufficiency, employment, innovation, and growth, and making farming a profitable profession. Srini possesses a varied experience in the technology sector, having previously worked as a senior product leader and general manager at Intel Corporation. We also have with us Dr. Beena Rai, who is the head of the Physical Sciences Research. She is a PhD from India's premier research institution, National Chemical Laboratory at Pune. Beena joined Tata Research Development and Design Center, then a division of TCS, the Tata Consultancy Service, 2 decades ago. Currently, she leads Physical Sciences Research Area in TCS Research and Innovation. Her pioneering research in computational material engineering, especially leveraging physics-based models and data analytics tools and techniques in the design. Development and deployment of materials and chemicals has led to the creation of top-notch research papers and 80+ patent applications. Her research has not only been instrumental in getting significant mindshare of TCS customers, but also resulted in significant revenues. With this, I invite the Tata Consultancy team, and I hand it over to Dr. Anand Krishnan for his keynote.
Thank you, Professor Kamakoti, and my pleasure to be here, and very happy to be part of this this very important event. I thought it would be a good opportunity for TCS to discuss with this August group on what we have been doing in agriculture and how do we see us playing some kind of a useful role as this partnership that we just saw being signed moves forward. I will kick things off, and then my two colleagues, senior colleagues, Srini, Dr. Srini and Dr. Beena will come in and present their parts of the overall story that I will describe to you in a minute. So Srini, if we can go to my first slide, please. So this is my one slide responsibility matrix. What is it that I do in TCS? But before I dive into that, I'll just introduce to you what TCS is all about. Tata Consultancy Services is part of India's most diversified, largest industrial group, the Tata Group. We are headquartered in India. We are India's largest, biggest, et cetera, most profitable, most valuable technology company. We are also, by virtue of our global presence, we are a very strong player in the Canadian market. I've spent a lot of time with our Canadian business headquartered in Toronto, just off University Avenue, very close to the university itself, right next to the Canada Life building, if you're familiar with downtown Toronto. What we do in our global business is to serve the world's largest corporations in multiple industries, whether industries ranging from pure services like banks and telecom companies and retailers, health companies and so on, to companies in manufacturing, companies in primary areas like mining and oil and gas and so on. And my job as Chief Technology Officer is to make sure that the research and development function, which is what you see on the left of this chart, is working well to support our global business. TCS Research has nearly 1,000 researchers. Both my colleagues are from TCS Research. And we essentially focus on the intersection of computing, like Professor Bhaskar Ramamurthy just mentioned. It's the intersection of computing with many different other sciences, which is our sweet spot. We do have a significant amount of research in computing itself, but we also work in computing as it works with physical sciences, which is the group that Beena leads, with life sciences, behavioral and mathematical sciences as well. We measure our research productivity fairly conventionally. We publish extensively, we file patents and so on. You see some of those statistics at the bottom of the chart. But it's not enough for us to do everything that we need internally. We have a very strong innovation partnership mindset. And most importantly, we run an innovation ecosystem. That's my second responsibility globally. And we work with every entity outside of TCS that's interested in working with us. My colleague Raju Goteti, who is based in Canada, actually he lives in Toronto, is the head of Co-Innovation Network, or COIN. We have a good set of relationships with Canadian universities. We've actually interacted with the Supercluster program in some of the other clusters, and so on. We work extensively with startups, with our strategic suppliers, with a lot of VCs and accelerators and so on, in a very, very win-win model. And lastly, my responsibility is innovation, which is the translation of all the good ideas which come from inside TCS, from research, from outside TCS, from the ecosystem, into new products and new services. So that's where the business impact and the social impact comes in. We partner significantly with IIT Madras in many ways. We have a research MOU with them, as we do with several of the other IITs and premier institutions in India and globally. And I really look forward to the opportunity to see how we can, as I said earlier, contribute to this initiative, which is very exciting for us. On the next slide, I'll try to explain our motivation of why we believe that TCS, which does not have a direct business, Srini, can you move to the next slide, please? TCS does not have a direct business yet in agriculture. That is Srini's mission in TCS Research and Innovation, to see whether we can build a business with both social impact as well as business impact in India and globally in and around agriculture. But if it was just that, we would not be doing justice to the opportunity as we see it to create impact. This chart essentially summarizes the way in which we believe that the larger TCS ecosystem can become a useful participant in the agriculture journey for TCS. This is a simple sort of 5-step evolution as we see it. Different players in the agriculture market, whether they are farmers, whether they are farming companies which supply inputs to the farming world, there are companies which are adjacent to the farming world, i.e. the people who buy the produce, add value to it and sell the products, or they are eventually the retailers, or they are eventually the even the banks, the insurances, the supply chain companies, and so on. As it happens, a lot of these surrounding companies and entities are customers of TCS. In Canada, for example, Farm Credit Canada, which is one of your important crown companies, which plays in this agricultural space, is a TCS customer. I've actually been to Regina and spent very enjoyable amounts of time learning how their business model works. And I learned there that Canadal, the lentil production in and around Regina, is actually shipped predominantly to countries like India. Right? So that's an example of an ecosystem play that TCS could now usefully intermediate. So this progression from a basic set of tools and methods and digitization of agriculture itself to ways by which the agriculture ecosystem can start adding value to agriculture itself, and it'll lead to some expansion and diversification. But then how do we now look beyond technology and expand that into multiple stakeholders, into platforms, and eventually universal marketplaces driven by data? That's the vision that we are driving towards. Now I'll request Dr. Srini to talk about specifically what he is planning to do in the sky and earth space. Where did our journey start? And then towards the end, Beena will come in and talk about the way in which she is looking at the value chain, specifically in the context of retail and food preservation and wastage. Over to you, Dr. Srini.
Thanks, Anant. Good morning, good evening to all. First of all, it's a pleasure to see Dr. Bhaskar, who taught me communications at IITM way back in the late 80s. Good evening, sir. And so in terms of our journey, we started our journey way back in 2007, when agriculture and technology were considered to be poles apart. Since then, we've made a lot of progress. We have understood what it means to be a farmer by literally living with the farmers. We've seen their problems at close hand, and through all these experiences, we have been able to scale up to over 2 million farmers. And we have got a lot of rewards and recognitions along the way, but our true reward is when a farmer comes to us and tells us how technology has changed his or her life. So in terms of the objectives, based on our experience, what we have realized is that technology alone is not enough. So we've got technology which can help in terms of the crop production and efficiency through a very efficient cyclic optimization process, which we call the 4A process. What we've also realized is for this technology to become truly affordable, we need to create sustainability by ensuring that vibrant technology-powered, data-driven ecosystems are developed, keeping the farmer at the center. And that's so with the twin engines which drive us are essentially these two. One is what we do on the field, and the second aspect is what we do off the field. So this is one of the farmers with whom we work. So I'll be sort of taking you through his journey, how technology has helped him. And if you look at this farmer, like all farmers in India and the rest of the world, they are literally bombarded by an onslaught of challenges which are changing both temporally as well as spatially. And so if you sum up all these challenges, you have this poor farmer who's sitting in the middle and who's completely distraught and not knowing what to do. So what's required is some sort of a personal assistant, something which can anticipate these challenges well before they happen. And that's where the power of data analytics and big data comes into the picture. And so we need to essentially go beyond what Google is doing right now for us, where we go to Google when we know what to search for. But typically the farmer, he or she doesn't even know what they need. And so it needs to literally anticipate. And so the way we have positioned our platform is a completely data-driven engine, which is continuously computing and providing insights to this farmer and directing him or her and telling him or her what to do next. So our expertise can be broken up into 4 buckets. So essentially, these buckets can be either deployed individually or 2 or more components can be converged to enhance value. And that's where the true power of data and the data interaction comes into the picture. So one example is, if I can change this. Yeah, one example is where we see how we are leveraging the power of sky and earth to enhance value. So at the sky level, we see how to enable the scale. So we look at getting scale, covering vast swaths of land through the sky analytics, and then we also obtain hotspots at the earth level through the data analytics algorithms which are employed. And then at the earth level, we look at what the system directs us in terms of what are the earth level interventions at those hotspots which are required. And then we essentially target this. So through the convergence of these 2 technologies, what we are enabling is firstly the scalability, secondly we are not losing out on accuracy, and thirdly that the whole technology intervention becomes affordable, and we are able to get down to plot level granularity through the clever interplay of these 2 technologies and harnessing the power of these 2. So putting all this together, what we have is, I'll just quickly get into the sky-based offerings. So these are some of the offerings which we have on the sky side. So I won't really get into the details because of the time factor. But to elaborate the hotspot identification, what we do is, so this is an actual tea estate in the northeast part where we have done this work. So we take the satellite images, we analyze it, we identify the hotspots, and then we decide what are the earth level interventions in terms of IoT or the field level, ground level interventions which need to be enabled. And by doing that, we are essentially converging these 2 technologies and managing what needs to be done in a very effective manner. And so completing the offering, so on the earth side, we heavily leverage image detection and data analytics at the earth side, and then also the IoT and various other aspects. And these 2 keep interacting with each other. So effectively what happens because of this interaction is, on the left hand side, you can see how a lot of these technology innovations come into the picture. So you have data of three types, which is below the ground, which is anything which we gather at the plant level or below the plant level. On the ground is at the plant level, and then above the ground is the data which we capture from the satellite images and the drones and so on. So all this data is continuously being collected. We aggregate it. We either send it to the cloud or we do the processing at the edge, and then this insights are distilled into what we call protocol capsules. And this protocol is like the DNA of this complete platform. So you can see, and it's something like the Aadhaar card, if people are familiar with it, for the piece of land, because of the wealth of insights and data which is being collected in this capsule. And then we move on to the right hand side where we get into the ecosystem. So here we have come up with special engines called PRIDES, which stands for Progressive Rural Integrated Digital Enterprise. So think of it like a legal farmer-owned entity at the village level, and the objective is to see how we can make this entity sustainable through all this business model innovations and the technology innovations. So effectively, we are through this intersection, we have been able to build up very effective and vibrant ecosystems. And coming to finally putting it all together, what we have done is we have essentially achieved through technology convergence on two axes. In the y-axis, we have been able to converge the sky and the earth, and been able to leverage the benefits of these two by having them synergistically work with each other. And then on the horizontal side, we are pretty much converging the what is happening on the field with what's happening out of the field as well. So by doing this, we are pretty much covering the entire agri value chain. We are enabling data transparency and insights, which are derived at one point, are percolated across the supply chain so that various decisions can be taken at those points as well. And all this is happening within the context of the 4A cyclic optimization engine, which I talked about at the beginning. So I'll now hand over to Dr. Beena, and she'll be talking about the food processing side, which happens after the harvesting and the post-harvesting side. Thank you. Over to you, Dr. Beena.
Thanks, Srini. Good morning, good evening, everyone. And thanks for the opportunity. So as Srini pointed out, he has showcased that how we are leveraging data-enabled technologies to help farmers produce more, better quality. I'm going to talk about that once the produce is there, when it is traversing through the supply chain, how do we ensure that we retain the quality and it reaches to end consumer, whether it's a retailer and finally the consumers like us, in the form it should reach. And especially the produce which are fresh produce like vegetables, fruits, dairy, meat, and so on and so forth. And motivation point of view, why it is important to work on this, because if you look at the left side of the box, we are producing, we are talking of precision agriculture, but at the same time, the wastage of food is very high. And people also remain hungry. So there is a gap in demand and supply. And also the wastage of food not only leads to the direct, you can say, deprivation of people in getting food, it also leads to environmental deterioration, because you can see that it also leads to CO2. It also leads to, of course, economic loss. But if one wants to reduce this wastage, what is required is an integrated platform which can help us actually monitor the food quality as it traverses to the lower end of the supply chain from the farm to consumer through the retailers. And obviously, it will reduce the wastage. It will also add to economic value. It will also be able to allow us to, in fact, repurpose the food, reach to the more needy people. So, Srini, if you can move to the next slide, please. So what are the challenges if one wants to build that kind of integrated platform which can actually monitor the food quality as it is traversing through the supply chain? The challenge here is the food actually degrades in different ways. There are different types of food. If you take fresh vegetables, if you take fruits, if you take dairy, meat, they have very, very different way of degrading with respect to environmental condition as it is traversing. And obviously, it is not possible to put sensors in each and every food item to keep monitoring. So how do one actually overcome this challenge? And that is what we are doing at TCS. What we are doing is we are actually using the knowledge of food chemistry to analyze food behavior, how it is going to actually behave under different supply chain scenario. So that is the offline analysis. We collect the data, as well as we also look at the online data, so sensory data. And collection of all this data leads to actually building of something called food digital twins. So these digital twins are actually the characteristics of food being captured using all this data, that how it is going to degrade over time with different environmental conditions. And here, the knowledge of food chemistry helps us, because even though food is, can you please go back to the previous slide? Even though food is of different classification, they can be categorized based on their food kinetics and enzymatic way of degradation into different classes. So here we can apply different digital technologies actually. Please move to the next slide. To in fact make these digital twins. So if you look at the bottom part here, basically this time sensory data coupled with food analytics data, which is happening in the laboratory, creates the twins. Now these twins act as soft sensor in the real time when we are doing minimal sensing in the field and predict the quality. Example here showcased here is for banana. As you see in the bottom picture, banana has 7 stages. When you pluck the ripe banana to become the ripened and most, you can say, delicious banana, there are 7 stages. And these stages are actually mapped to the chemistry. So there are different gases which peak when banana becomes completely ripened. And if all the data collected in the lab actually mapped to that, and finally to images. So if you look at the bottom of the chart, there is a mobile phone pointing at the bunch of banana. This is actually at the retailer end, likes of Walmart. Actually, this was taken with our own group company, where one actually retailer is just pointing the phone and taking the picture. But since this soft sensor is working in the cloud, it is able to tell that this banana is going to last for next 3 days. Right now it is at the ripening stage 3, but to reach at ripening stage 7, it will take 3 days. So if you want to consume after 3 days, then please pick it up. But if you don't want to consume after 3 days, you want for today, then you may have to choose another bunch and so on and so forth. So this is how this whole technology works. And since we are using here the food chemistry knowledge, we are able to actually transfer the knowledge from one class of food to another. So we don't have to keep collecting data for each food item, but we make the generic models which work across the type of food. And that's how it is a scalable solution. And we have done for many, many other, you can say, classes of food. So in want of time, we are not going to showcase that. So at the end, what I want to summarize, Anand started with this whole ecosystem view where TCS would like to be in business with agriculture, concerning agriculture, right from growing food to even all the allied businesses across the value chain. And Srini talked about how we can help our farmers to, in fact, to improve their livelihood. And finally, I talked about once we have grown the food, how we can actually complete the value chain so that we retain the quality and it reaches to the end consumer likes. us or the retailers. Thank you.
Thank you,
Thank
Bina,
you.
and we'll be happy to take questions.
Yes, questions from the audience. You can please type your questions on the chat. Question to Ms. Bina. What exactly is the sensing technology for banana? Is it transmission?
Transpiration.
Sorry, yeah.
It is not transmission. Actually, we are doing the sensing of various gases coming out of banana. For example, carbon dioxide, ethylene are the gases, and they are mapped to the ripening kinetics of banana. So the curve I was showing. So when the banana is completely ripened, the peak is taxing. So we use that data to build that soft sensor.
Right. But how do you sense it? Is gas is calibrated with the color, or is gas used for ripening banana? So there are two questions. Yes. So one is that what is the sensing technology that is used? How do you find out that it has ripened? So that's the question.
Yes, so we use gas sensors to measure the actually amount of gas coming out with it's a time series data, and we also continuously capture the imaging. So finally, we use this machine learned model to map the images to the measured sensor data, and that's how you build the model.
Is gas used for ripening banana?
No, it is a natural ripening, takes 7 stages. And that is why you would have noticed when we buy from the market, if it is treated with the ripening agent, you will see you bought the green banana, next day it becomes completely yellow and ripened. Whereas natural kinetics take 7 days. So you talked about organic food. If you want to have a chemical-free banana, it should take 7 days from green to completely ripe.
Sure. Are you running some kind of state estimation or statistical inferencing algorithm underneath the soft sensor?
Yeah, these are machine learned models here we are doing. So this data is used to build machine learning.
Sure. So the next is a very good. How to catch if seller using gas for ripening? Is there a way by which we can catch if the seller is actually using gas for ripening?
Yes, of course. If you have so we have in fact tried Intel. We have also built a very frugal handheld device, which in fact is very cheap. So even we can keep at home and measure the ethylene there. And if you see that ethylene quantity, you can map with the graph and see whether if the ripening process is hastening, that means it is treated with ripening agent. If not, it will take that 7 days, which I talked about.
One more question, checking if TCS also has plugged in blockchain into this. I think Anant.
Anant has to answer that.
Sir, the answer is no. Blockchain is a hammer which can kill many nails. We have chosen not to kill this nail with it.
Okay. Is your technology helping small farmers?
Yeah, so the majority of the 2 million farmers we have are small farmers.
Okay.
And we have definitely seen how technology has been able to improve the standard of living of the farmers and make them more prosperous.
So there is a comment from a professor of physics that there are techniques based on luminescence.
Yeah, there are many actually players in this. There are a lot of even startups which have this kind of devices which talked about shelf life predictions. So basically, yes. But what we have realized that if you want a scalable and general model, we have to go the road which we have sort of started to talk. Because you can make it very specific to one particular food item. But if you want a very generic and scalable solution, then this is the way to do it. That's in our opinion. We may be wrong.
So we have 3 more. We'll just stop with these 3 questions. Is TCS thinking venturing into farm mechanization space, say tractor or improved implements as well?
No, we are not doing it directly. So we help some of our partners who are into farm mechanization get data from the field, but we are not getting into it directly. So we also work with big corporations like John Deere and so on, and CNHI, and see how a tractor which cause an intelligent tractor or a farm machine which costs $1 million plus in the US, how we can get it down to maybe $10,000 or so in India and make it more affordable by using IoT and so on.
So I'll just clarify the question, Dr. Kamakoti, with your permission.
Yes, sir. Yes, please.
M-Krishi, which is one of the questions that has been asked, and digital farming. So M-Krishi is the social, or actually was the original name for the social face of this digital farming initiative. For many years, it was kept only as a social program by both TCS and Tata Group. In the last 3 or 4 years, we have taken the technology and we are now trying to globalize it under the name DFI, which is the technology name for whatever Srini described. M-Krishi as a social program is now going to be made available and has been made available to the Tata Trusts, Tata Chemicals Foundation, and many other charitable institutions for taking forward on the same platform, but for social purposes. So TCS is slowly going to be getting out of M-Krishi as a name. We will be talking about our technology, which is DFI. So we will not be an active player in as ourselves. We will always be working through some entity which will take us to market, either one of our customers or one of our social partners.
Thank you. So last 2 questions. The DFI, do you incorporate meteorological data in DFI?
Yeah, metadata is a very key component. So a lot of the disease and pest prediction, we heavily rely on the meteorological data. And internally also, we are doing a lot of research in terms of seeing how we can use interpolation techniques and so on to improve the accuracy of the metadata, and be also able to predict anomalies like hailstorm and so on.
The last question. Thank you, Srini. Last question. Currently, is there any mobile app which can check the time period remaining for ripening, or are you planning to develop any in near future?
Yes, so the mobile app you saw, actually it's in development stage, so it is only internally we have tested it, but yes, we will be deploying it here. So it is already there.
Sure. Thank you very much.
Well, thank you very much, Professor. That was a terrific opening keynote and really does set the stage for our next speaker. So our next speaker is Mark Alexiak, and Mark is one of the co-founders and the Chief Science Officer at Sightline Innovation. Mark and his colleagues at Sightline are actually part of one of our precision agriculture projects as part of the Digital Supercluster, and they have been one of the first companies in Canada to develop the data trust technology and apply AI platforms in order to enable enterprises to really control the data, derive the value, and gain much better insights. So without further ado, I'd like to introduce Mark to deliver his keynote. Mark, over to you.
Hi, thank you very much for the introduction and for the opportunity to speak today. It's a privilege. I'm sorry that my camera is not working at the moment. However, I would like to talk to you about creating a data trust. Originally, I believe that the topic of conversation revolved around data management. And so this is a very important topic for me. My background is from computer and electrical engineering, and I did my grad work with the Canadian National Research Council Institute for Bioinformatics. And so it focused more on medical, but both in medical and in agriculture, you know, understanding data provenance and data standards are very important. I'm very happy that several members of the TCS have been to Toronto and also Regina. This is what the prairie looks like where I'm from. I'm in Winnipeg, right in the middle of Canada. And so what is Sightline and what are we doing? Sightline is a startup company in technology. Very early on, we were working with the University of Guelph, which is a very famous Canadian university for ag, and with drones taking hyperspectral imaging. And in our experience in the industry, we have looked at applied artificial intelligence in different industries, from manufacturing, identifying parts, as well as defects, getting into medical with some genomics analysis, and also looking at digital ag, of course, where there's many complex problems involved in gene to trait mapping. I'm glad also about the ripening bananas. One time in the store, I saw a package of a yellow banana and a lightly green banana and a darker green banana, and it's like, it's great for having a perfectly ripe banana every day. So I want to talk to you about creating a data trust and why you might want to do that, who would likely be involved, and maybe some rules for playing nicely, and then talk about some of the technologies that are involved and what Sightline has been doing with all of our painful lessons learned in applied AI. I think the previous speakers mentioned a little bit about all of the confounding questions that are presented to someone who's trying to run a business, especially a small business, with many variables that they don't control. And so, we definitely want to take advantage of public data sets, of local knowledge, of ground truthing to feed back into making those correct decisions at the right time. So a data trust, I'm going to explain a little bit more about what it is, but this is, there's many governance standards, GDPR, California Consumer Protection Act. There's lots of risks in different industries about leaking data, and it's very important to understand, where it is and who's using it. One of the nice things about distributed computing is that it is possible to keep the data in place within the IT policies and firewalls and governance structure where it was acquired. So there's people that make sensors, there's people that acquire, there's data lakes and data warehouses. And if you can send a query to the data securely, or send the AI model to be trained where the data lives without sending the data over the network, that seems to be kind of a better way to go. And one of the things too is that if you have a common interface to accessing the data, then you can create a comprehensive audit trail. So this is a kind of a goal that a system should have. Why use a data trust? So save money on data operations. And so one simple way to think about this is people spend a lot of money putting satellites into space, and there's very expensive sensors on the satellites, and there needs to be, that cost needs to be recouped through the value chain. And so every individual farmer, having an individual contract to acquire the type of data that they need at the right time for their growing season, is expensive. But by working as a cooperative or another kind of way, you can purchase the asset and have it used in different ways. So there's a lot of things that we have thought about in developing a platform that can address some of these things. By putting data or access to data or different value adds, because when I think about data, this really applies to digital assets. And so this can be raw data sets, it can be curated data sets, it can be implementation of an AI model, or even better, it could be AI model trained on the exact kind of data that you want to be discriminating on in the fields to make correct decisions. And it can be a mobile app that helps you make that decision by scanning a picture of your field or whatnot. It also helps us to enable responsible data mining. So one of the things that medical companies do is they don't let you ask queries that identify individuals. And so there's some of these concepts around ethics around AI that are certainly involved. And of course, you want to realize long-term value. So I think a key goal in any kind of project is to have what you create live after the project is done. And so When you look on GitHub and you see open source projects or the Linux Foundation or the Cloud Native Computing Foundation, there's many volunteer hours of great expertise poured into these things, and they live after the original contributors have moved on. And so, especially with government-funded projects, you want an ecosystem to be created that's self-sustaining, that has a clear mandate and a goal to live on. And there has to be, with all these IoT and data, there needs to be a way to show how these data and insights have financial and business value. So this is an interesting slide. There's a lot of things that I can say, but if I find that Deloitte or KPMG or other people are also saying this thing, I like to give them a chance to show how this feeling is shared amongst many different people in the industry. And there have been in the last 5 to 10 years different data marketplaces, places where you could go to access these things. And in a sense, data is the new oil or the new plutonium, I think some people have said too. But it really does drive a lot of this kind of economy in many different industries. And so one of the things that I can see in Canada, in my home province as well, is that more data is being made available online. And especially meteorological data has very good public funding and availability. And these things have an API. And so if you have an application programming interface, you have open protocols, you can build an ecosystem of closed and open source software in an open architecture that can grow and address these kinds of needs. So just showing mainly here that, to be cognizant of government, business, and individuals working together in this field. So just a recent article showing again, that when we talk about not only digital agriculture, but also the supply chain of logistics and processors, and I'm so glad to know now that there's thousands of types of rice in India. I would like to, why not try them all? And so if you have this decommoditized ag input, and you're collecting data on it, and there's a supply chain, and you have all these different things to get it to the consumer, there's a lot of questions that arise between these different entities who are processing it, transporting it, packaging it, certifying it, that they each have a little bit of the puzzle of how to get high quality product to the consumer. And of course, there's lots of questions about who owns the data and how can it be used amongst this value chain. Of course, there's no risk to working in applied AI. I'm sure there's many stories about people that have started on a problem that seemed to have a very good scope, and then the data format changed, or the technology library that they were relying on came out with a new version that wasn't backwards compatible. There's many different things. And so one of the nice things about a data trust is it does give you another tool for pooling risk. And as part of that process, of course, you identify it and put mitigators in place and monitor. This slide, I'm just trying to show again that many different types of organizations collaborate on a product idea. It could be a new ingredient that's going to be used in food. One of our digital agriculture projects works to develop a higher protein yellow pea. Will that higher protein yellow pea affect the flavor? What kind of food should it be involved in? The other one that we're involved is working with gene trait mapping around rust-resistant wheat. There's many interesting problems to look at here. And I guess one of the things here is that the partners will be contributing at different times. And often when you're patching together a project, different funding avenues also are available at different times. And so a data trust can help you capture the preliminary data to get the grant, or to demonstrate to the business community that this is something that is valuable. And a data trust can also help you do the reproducible science. You know, like when you do an investment, you want to do some due diligence, show me that it works. This can help. Digital ag is exciting, I think, to me, because there's many complex problems, and yet you have to work within a business envelope. And especially the example that was provided with a small farmer who has 2 acres. You know, it does put a strong cost envelope around the solution, which drives innovation to you know, find a better solution with what's available. So this is, you know, in these projects, I do have the opportunity to work with plant breeders, agronomists, and, you know, people that are in the field. So there's motivation, I think, to develop the data trust and the surrounding processes and technologies to this. And you know, one of the things too is highly qualified personnel. There's huge opportunities for people who maybe have a biology or plant background, but are not comfortable with technology, or for technology people to understand another area where there's a great problem to solve. So it's very clear there's lots of motivation. When you work with other people, you do want transparency, and you do want to be part of the decisions and to know, you know, really what you are being asked to do. So if I expand the concept from a data trust to you know, a trust of digital assets. You know, people don't like to put their software on the web. They don't like to put their data where they can be at risk of liability. And so within a data trust, there's many points to refine how things are shared, when they're shared, under what conditions they are shared, and monitoring to make sure that this does happen the way that is intended. Okay, so stakeholders' motivation, we understand why. What and how exactly, and is there anything to be aware of? There's lots of these kinds of sheets when you're doing like a business case or anything, you know, fill out the fields and it'll go swimmingly. Master data is something that's important in many industries, and these different types of data change at different rates, and they have different sizes and different formats, and these things can also change over time. But you know, this is some of the things that you can expect to see in the end system. There's also some treaties that relate to, you know, biodiversity, for patents and protecting new plants. And so when you know, one of the certifications that you can think about, you know, also is, you know, is my processes compliant with this thing? Can I get a certification? And there you go. You've perhaps decommodified what was previously a commodity. There's many different types of sensors. The electromagnetic spectrum can interrogate plants at different stages of their life cycle and their qualities. And I thought it was, you know, helpful if you think about, you know, how much data, you know, are we going to have a lot of data warehouses storing these things? If I want to go, you know, just per crop, how many varietals do you want to do? How many seasons? You know, where's corresponding soil conditions and weather that I can use to have a larger data set to train a better classifier. You know, this is kind of the numbers that you're looking at, and the spectrum that has different interesting information. So again, one of the things too that I realized is that with different satellites, there are some free satellites, but they don't go over the same areas with the same frequency. They perhaps don't have the same sensors. And so one of these services that satellite imagery companies are coming up with is kind of a mosaicing of overlaying information acquired from different sources over the same region to provide a richer set of data for making decisions. So EO, Earth observation, a very interesting area right now. And what does it really mean? So, looking at these different ranges, you can look at different aspects of cellulose, plant area, content of water, and some stress. And so this just doesn't stop. So your data trust system has to be extendable to accommodate associating new data sets with previous data sets and changing formats as these data content changes. There are many people working in this space, and the farm management software with agronomists taking this information and giving advice, having sensors in the soil, on the tractor, handheld, in the sky. One of the interesting problems that my colleague is working on is taking pictures with drones. And part of the challenge with gene to trait mapping is looking at complex traits like yield or disease resistance, where you are going through a breeding program and you're trying to associate to get a homogeneous seventh generation, but you don't know which ones to cross to get there. And so some of these genes manifest themselves with phenotypes, and so that you can look for standability or leaf shape to infer what genes are active and do your selection for the next generation. So lots of opportunity, but also challenges with that. So if you reduce scope to maybe just thinking about, oh, I just want to measure the leaf size because I know that the leaf size is going to be related to yield, and this will help me. We can think about what are some of the stages that need to be processed in this data pipeline for that to happen. So you have a camera, it's a type of camera, you're measuring something. Image segmentation is a very well-known problem with many solutions, and then there's many different techniques again to segment individual aspects of that. And so as you go through this training set, this analysis, this decomposition, you get a solution that works for some plant with some camera angle, with some type of camera, and it works. And you want to preserve your investment in that, and so having that as a service within a data trust for other people to use, and you can monitor how often they're using it and what kind of things they're using it for. That'll help give you, a measure of value on what you've created, but also give you advice on what to create next. A data trust has to be something that's useful, and the people that come to it are going to have many different problems to solve. And there's many different ways to solve those kinds of things. So even just within the field of digital agriculture, looking at genomic and proteomics and metabolomics, there's many great minds that are working to solve these problems, and each of them are developing little, I call them little, but with respect to the many things that are going on, there's many little things going on. How do I know when I'm starting my problem, which of these things is the right thing for my solution? A lot of this software has open source MIT BSD licenses. It's free to use, and so there's no cost in that sense. But how do I package it up with my other things that I want to do? And so I'll show you a little bit later as we get into the software development kit and the technologies that we use with containerization. And Kubernetes, this can be packaged in and added to your pipeline for your problem. What does this kind of look like from other types of sensors and problems? This is a satellite and NDVI of some fields. You can monitor, look at your hotspots. This is all good. And one thing that you need to think about for AI problems is always ground truthing. So can I text someone on the ground to go and take a picture of this hotspot to confirm that this is the root cause? And so data quality is a big part of data management, and you can't rely exactly on always what the sensor shows without having the ability to go and verify yourself. So the whole class of supervised learning models requires that kind of gold standard. And again, just some really exciting thing about non-destructive high throughput plant phenotyping as well to monitor these things. We are active in a collaboration with the University of Winnipeg, for example. They have some growth chambers where they have a robot arm taking multiple camera angle pictures of these plants as they grow. And this will be something that the Canadian government has funded and will be available to Canadian researchers and ultimately to researchers around the world. And of course, everybody knows that you just can't consider genetics. You have to consider the environment, and you know, just the range of plasticity that plants have is just phenomenal. And again, you know, looking at how a disease manifests itself. I don't know of how disease detection can be exhibited and captured within a satellite, but you know, so you have to have like different ranges of your sensors as well. And again, just looking at how you know, even water volumes can be assessed to advise irrigation programs. So this is what it looks like. Ultimately, we do want to go down to, you know, taking these data sets at different resolution down to advice that has the impact on day-to-day activities. I appreciate the comment that blockchain can hit many nails. And so I often describe our offering as smart contract ready. If you want to use it, there's a way to plug it in, but the access control can be hooked into blockchain as needed. Okay, so we have stakeholders, we have data, we have sensors, and we're just going to buy AI from some big vendor and we'll go to town. Well, that's great, except that it's not true. And so a data trust helps you capture some of the experience as you test out your research hypothesis. You know, any good researcher doesn't come to the party with one research hypothesis. There's a family of them, and so you need to be ready to adapt as you interrogate reality. So, you know, going back to data management, you know, you do capture an initial research hypothesis. You want to make sure that you're planning to capture the right data. You do capture what you have. You measure it, and then it doesn't work. So what's going on? So you have to be able to go back. All the software engineering principles of configuration control, documentation, testing, continuous integration. You know, this all helps you here, but there is an aspect to data quality. And when we think about, you know, taking pictures of plants growing in a growth chamber, that's great. But the camera on the tractor is not necessarily going to be the same as the camera in the lab. In the growth chamber, not going to be the same as the camera in the field. And many people get frustrated by, you know, shadows or wrong angles or too close or not enough information. But there's many other things that can happen to your data in the cloud or in your local server. You know, just there's lots of hand touches and things just happen. So okay. And unfortunately, I wasn't able to find plant pictures for this, but thinking about data quality and data management. So you have this AI black box, and you send it an input here, and so you train it on 1 million cats from the internet, like they did in 2012, and it works. And then someone takes a picture of their German Shepherd and photoshops it or deep fakes it or something, and they're going to try and run it through it, right? So if you're thinking about robust supply chains and certification and automating there needs to be an aspect of security or vetting or humans in the loop. So, you know, this is what the AI says. Do I understand why the AI is making that decision? And is it possible to have a human in the loop? So I think most of us, you know, if we didn't do a quick glance, you know, this is a cat on the left, this is a dog on the right. But if we look at the picture on the left here, very few of us would think it's a computer. And yet this is an example a few years ago from an OpenAI and Google Brain, where by a deep understanding of the object detection system, a small bit of noise was added to the original image of the kitten to fake out the AI involved. And again, so, you know, that on the right there, that is a picture of a banana and not a picture of a toaster. Okay, so this is someone who's gaming the system pretty hard. This is kind of what it looks like. If you look, think about this noise as epsilon being a small value. Most of the AI models don't come out with just this is that. I think this picture is a picture of a panda. They also come out with a posterior probability. And so on the left-hand side, you see a panda image going in, and on the bottom it says this is a panda, and I'm almost 60% confident that it's a panda. But with a deep knowledge of the system and some small epsilon value, I can put that basically the same image in there. Visually, it's fairly indistinguishable, but the output of the AI system says that it's very much almost 100% sure that it is a given. So again, just an example here. The worst case that I found here is this obviously is a picture of a turtle, but with deep knowledge and a special edge case here, this is classified as a rifle. Does that have my 5-minute warning?
That is.
Thank you very much. Okay, so let's not just do curve fitting. Let's try and understand the causal framework, and let's do that within a data trust. One of the things we do is we take advantage of the Linux Foundation's cloud computing foundation graduates. So they have things that are scalable. Rancher Kubernetes engine goes from 10,000 clusters to 100,000 nodes. This is the backbone of our digital fabric where data producers, data consumers can interact with digital assets, AI models, curated data sets to impact their operations. This is kind of what it looks like. The distributed data assets are data that lives in your location, on your farm, in your warehouse. It interacts with our digital backbone with identity and authentication over a software-defined wide area network in order to be combined with something that's going to affect the business decision point. And so this is what it is. This is what we're building. This is what creating a data trust looks like with our platform. You can create a list of members to it. And as you add digital assets, they'll be included within a subdomain on this virtual private network with appropriate capabilities for what you want to do. This is an example of someone logging in and seeing several applications that they have been granted access to. This is a dashboard of some of the cloud resources that are being consumed by this particular, I'm not sure, this is an app, but you can do this for your S3 buckets or your mounted file systems as well. If you log in and nothing's been shared with you, you'll see nothing. So that's what you want. You can manage users, and there's a way to monitor the audit trails for access to different assets, and that can be compared to what the kind of contract is. So this is what we do. We're using this for digital agriculture, as I mentioned, but also for other industries. And we're very interested in supporting this. This is just a quick code example because what engineer can't not show a slice of code. But with the software development kit, we can package up, it doesn't matter if you're using Julia, R, Python with containerization and our software development kit, your digital asset can be hosted in this secure environment for use to improve your operations. So thank you very much for your time, and I look forward to talking to some questions.
Very much, Mark. That was a very insightful and in-depth presentation. And maybe what we can do is open up the chat window and see if anyone has some questions that they might direct to Mark. Okay, thank you for the question, Prem. The question is chlorophyll sensing. It's done by only NDVI image of PS2 or any other complementary data that with time resolve decay analysis in pico lasers. There's a lot of technology there, so hopefully Mark, you can answer that question.
That's a great question. I don't know about that particularly. I do have some experience. We were working one time with the Government of Canada on colorimetric sensor arrays for volatile organic compounds. And so it's like a fancy litmus test. I don't know. I'd be interested to know. Sorry.
We have another question from Arun. Hang on one second. How much of the work has been done or is being devoted in the AI on the sensitivity of its algorithms to uncertainties in data?
Another great question. And so this is something that is very much at the forefront of the mind of the community. There's many conferences and papers now about the ethics of AI. You may have seen even in the popular news how some AI models were trained on white males, but not on other diverse members of our society, and yet they were being deployed. There are shopping malls in my city where they were taking pictures of people to identify gender and age in order to do targeted advertising, but there was no consent. And so I think there's like kind of two key aspects to this. Obviously, one is what does society feel is appropriate for uses of AI? And then there's kind of a more just technical problem, like what are the edge cases? And so it's very important, I think, when you do AI to understand the methodology. There's techniques by which you create training and testing sets. You never present your test set to the model in training mode. You have a validation stage. You do monitoring. So one of the techniques that we did, it was involved in a factory with a conveyor belt that got dirty. That's fine, makes sense. It went from bright green to a dirty blue over a period of weeks, but we had to do foreground background segmentation of the parts, car parts that were on that conveyor belt. And so we were monitoring the posterior probabilities as a trend in time to determine when the classifier should be retrained on this new background. So great question, and each algorithm really has its own idiosyncrasies for edge cases.
Thank you very much, Mark, and thank you for the questions. I think this is a perfect segue to our next speaker. Let me take this opportunity now to introduce and welcome Keith Janza. As it happens, Keith has worked on many of the data standards in Canada, and he is the Executive Director of the CIO Strategy Council. He works with many of Canada's forward-thinking public and private sector chief information officers, really to look at digital transformation and how we can advance Canada's agenda on the digital economy. So without further ado, over to you, Keith.
Thank you, Bill, and it's a pleasure to be here. And I won't take too much of your time. I hope to actually open it up a little bit for any questions or comments. So just very high level, the CIO Strategy Council is Canada's only national forum bringing together the country's most forward-thinking chief information officers and executive tech leaders to collectively mobilize on common digital priorities. Cutting across major sectors of the Canadian economy, both public and private, the Council harnesses the collective expertise and action of Canada's CIOs to propel Canada as a digital-first nation. With a strategic and coordinated approach, our members are helping to inform the design of disruptive technologies and accelerating their adoption across all industries, resulting in a safer, more prosperous ICT ecosystem in Canada. One of the ways in which we're effectively leading the charge here and providing the signals to the marketplace as to the expectations of products and services is through standardization. We are an accredited standard development organization here in Canada, developing national standards for the digital economy. And through our agile, open by default, consensus-based approach, the Council continues to maintain its accreditation from Standards Council of Canada and has effectively accelerated the standard setting process to match the speed of innovation and advancement in ICT. We're essentially developing new standards in months, not years, and making them readily available at no cost to organizations and individuals, aligning to our mandate around transforming the digital ecosystem and ensuring that when it comes to ethical requirements around AI systems, or the way in which data is being governed, effectively having those requirements and guidance available in the marketplace, and to, of course, Canadians and citizens alike, is extremely important. So comprised of hundreds of thought leaders and experts cutting across various economic sectors from coast to coast to coast. The hard work of these technical committees are effectively have effectively published 4 national standards to date. Those standards include the ethical design and use of automated decision systems, around data governance, the digital protection of digital assets, third-party access to data, and most recently, a standard for digital trust and identity, particularly on the fundamentals of digital identity. There are a number of other standards within data governance that are effectively in development. There's over a dozen projects. Any stakeholder can engage in this process, whether it's academia, industry, civil society groups, governments, policymakers, and the like. It is not limited to members of council. So like I said earlier, this is an open, by default, fully transparent process, and effectively codifying voluntary standards that can effectively be used by CIOs and tech leaders in their procurement, into potentially informing public policy and future regulation, and those types of policy levers or policy instrument levers that exist in the ecosystem. With respect to data governance specifically, 2 of those standards being published, like as mentioned, the third-party access to data and the data protection one. There are standards in development around the de-identification of data, health data and information capabilities, the qualification and certification of big data and machine learning personnel. So very much looking not only at an organization's governance and its practices, but also core to the technology itself. And then likewise, the skills and qualifications that are required to instill the trust, and again, signal to the marketplace as to the expectations on products, services, and people. I should note, and just given the earlier conversation around data trusts, the Council is actively pursuing new parts of its series of data governance standards on responsible data stewardship, data sovereignty, and copyless data integration. Important to note around the data trust piece, or the data stewardship, it's around first, responsible data stewardship. The proposed national standard, which is slated to be tabled for our Council's Standards Policy Committee, that is made up of a subset of our members that effectively govern our process and approve new work of the Council. They will have this proposal tabled, of which they will be discussing a proposed national standard that specifies minimum requirements for the architecture and governance of responsible data trusts, collaboratives, and cooperatives. The standard will essentially apply to the fiduciary stewardship, accountability, and management in the collection and exchange of data. Likely very much a topic of interest amongst this group, and certainly as this proposal is tabled and the Council considers the merits and the strategic need in developing such a national standard for the country, given the collective interest, not only around this table, but others around the country. Again, stakeholders here and across Canada will be able to engage in and help effectively build the requirements that will make up the national standard of Canada in the future. And so with that, I will open it up for any comments or questions around the Council, its standards process, or any of the standards work that's currently taking place. Additionally, just to add, any standards proposal can be provided by any stakeholder into the CIO Strategy Council for consideration. So again, through whether it's the Digital Supercluster or other networks, again, there is the ability for any stakeholder to propose new work where there are identified gaps and a strategic need to fill, to help inform public policy, to help inform and provide those signals to the marketplace as to the expectations of products, services, and people. With that, over back to you, Bill.
Thank you so much, Keith. And we can open up the chat to any questions that might arise. Maybe I'll just start, Keith, and maybe ask the question of how does the work that you're undertaking with Council ladder up to international cooperation initiatives?
No, very good question. So we, in recognizing the importance of digital cooperation, not only here in Canada, but abroad, we are a founding member and currently are the secretariat to a group called Oceanus. It's an open global forum that was initially struck by national standards bodies across the world coming together to have effectively conversations around standardization for autonomous intelligence systems, around data governance, around these critical areas where effectively coordinating amongst each other to ensure that we're avoiding duplication of effort, that we are aligning and creating joint work where it's possible, where our values align and these sorts of things. So that group has effectively provided us a forum to have these conversations where it's not about developing standards through that forum, but it's about having the conversation around the organizations that do develop standards to effectively coordinate. So as much as we are developing national standards for Canada, they are very much fit for use. They are governed under the WTO principles and requirements around preparing of standards and their adoption. And likewise, as much as Canadians and through the Digital Technology Supercluster, we want to get products to market quickly, get that first mover advantage, compete globally. Well, so too is real of standard setting. You want to be first to market with the standards so that, again, organizations and countries from around the world react to. We heard it in the earlier presentation around GDPR. We saw what that has effectively done to other parts of the world, even though it's a European regulation, but it has impacts around the world. Again, Canada can play a leading role when it comes to things like data trusts and otherwise, where we're effectively codifying in a way that impacts other economies, and doing it through an accredited standardization process puts us on a level playing field to other parts of the world to be able to do just that.
That's terrific, Keith. Thank you for that. And that's a great segue to the next segment of this workshop, where we have the opportunity to have an interactive conversation with Mark Sheehan and as well as Professor Kamakoti. And the heart of this is really to look at what is a potential framework for data sharing between our countries. So it's my pleasure now to introduce Mark Sheehan. He is the Associate Assistant Deputy Minister for Strategy and Innovation Policy at the Department of Innovation, Science and Economic Development in Canada. Mark has, in his role, he's responsible for advancing the government's microeconomic policy agenda and supporting the development of the department's horizontal policy and strategic priorities, including ensuring robust marketplace frameworks and telecommunications policy, as well as deepening external relations across the industry. So without further ado, let me introduce Mark. Over to you.
Thanks so much, Bill. Really great to be here, and it's a pleasure to speak at this austere workshop to discuss the role of big data in the agricultural sector. And I'd like to thank you, Stu Beck, the Asia Pacific Foundation, the IITM-Pravartak Technologies Foundation, and the Digital Supercluster for organizing today's event. I'd like to begin by saying that Canada and India obviously have many strengths in data and digital technologies, and we look forward to continuing our bilateral engagement as we proceed along the road to a post-COVID-19 economic recovery. The accelerating digitization of our economies, accentuated by the global pandemic, holds opportunity for every sector and size of business to grow, an opportunity for enhancing global competitiveness for an inclusive, sustainable, and shared future. But I think what I'm here to talk about today is really this opportunity in big data and the opportunity that it holds for this sector in particular. And large-scale data collection and analytics are becoming ever more crucial to realizing the economic potential of emerging technologies and the digital economy across many sectors of economic activity, including agriculture. We've heard some fantastic examples earlier today about the specific use cases in far greater detail and along technologies that are way beyond my realm, but to say I'll speak to the sort of framework elements of this. So the innovation superclusters unveiled by the government in 2019 are obviously a key to our long-term competitiveness, which will only be sustained in the long run with focused investments in our domestic innovation ecosystem. And so the Supercluster's initiative, which was $950 million over 5 years to stimulate large-scale collaboration among industry leaders, small and medium-sized enterprises, and post-secondary institutions, are to develop and scale high-potential technologies in Canada. And so this is a great example of our investments to nurture innovation, whose objective is to unlock the potential of data in cross-cutting sectors, such as data visualization, data analysis, and data collection. And this includes expertise in technologies like AI, nanotechnology, quantum computing, and robotics. The Supercluster seeks to arm Canadians with the best data to drive decision-making and connect the digital and physical worlds. So the collection and management of agricultural data will complement efforts such as the Precision Agriculture to Improve Crop Health project, which is led by Terramera, that will develop new pest and pathogen controls through the application of computational biochemistry, genomics, machine learning, and robotics to manage disease in field crops, minimize the use of pesticides, and secure export markets. The Scale AI and protein industry superclusters are also developing projects to improve the experience and competitiveness of Canadian agricultural producers, including the areas of supply chain optimization, novel processing technology for canola and hemp crops, and weed and pest control. Data management, sharing, and governance will be significant cross-cutting aspects across all 5 superclusters, particularly as they leverage emerging technologies like AI. But harnessing the promise of big data in advancing innovation-driven economic development requires effective data governance that ensures data is consistent and trustworthy and does not get misused. It is more and more critical as organizations face new data privacy regulations and increasingly rely on data analytics to help optimize operations and drive business decision-making. As many of you may know, in May 2019, the Government of Canada launched Canada's Digital Charter, which outlines 10 principles to guide the modernization of Canada's marketplace frameworks in a manner that encourages trust in the digital marketplace and enables organizations to harness the power of digital and data transformation. The 10 principles are based on key policy themes and challenges, including access to digital infrastructures and data, effective use of emerging technologies and data, enabling innovation, inclusive job creation, prosperity for all, enhancing trust in the digital economy, supporting open business environments, and interoperable regimes. Under the Digital Charter, we've committed to enhancing Canada's privacy framework to support continued trust and adoption of innovative technologies and business models by examining proposals to modernize our Private Sector Privacy Act, which is a very long title, the Personal Information Protection and Electronic Documents Act, or PIPEDA, which essentially is our private sector privacy law. Many of these proposals within the discussion paper that we launched at the same time as the Digital Charter speak to the issues we've talked about today. They're proposals that are aimed at encouraging responsible innovation by industry, including data sharing governance structures such as data trusts or other mechanisms, which would provide a secure and privacy-enhancing means to share data and spur the development of artificial intelligence innovations. Moreover, Canada has made strong efforts to support standardization in data governance. In May of last year, the Standards Council of Canada convened a data governance standardization collaborative. The collaborative, which includes representatives from academia, civil society, consumers, standards organizations, government, and industry, is developing a roadmap for data governance in Canada. The roadmap, with its life cycle approach, will include elements from data collection through access and sharing and ending with data analytics and commercialization. It will also include standardization considerations related to data access rights and related credential validation, as well as data interoperability within specific data sharing governance structures, such as a data trust or other mechanisms. And that roadmap is expected to be published by the end of 2020. The collaborative also intends to identify gaps in standards, including at the international level, and further international standards work will be assessed following the completion of the roadmap. Canada is also working with India through the Global Partnership on Artificial Intelligence, and I think we'll hear more about that shortly, to facilitate safe multi-stakeholder experimentation on key AI issues, such as data governance, in order to advance the global body of knowledge on the responsible development and use of this technology. This is why data governance was one of the 4 GPAY working group themes identified for the first years. This working group supports cutting-edge research and applied AI projects with the objective of promoting the collection, use, sharing, archiving, and deletion of data for AI in ways that are consistent with our shared commitment to the OECD principles on trustworthy AI. And in this respect, we're privileged to have Professor Kamakodi participating in the data governance working group. In total, the Data Governance Working Group brings together 30 leading experts from industry, civil society, governments, and academia. Supported by a center of expertise in Montreal, the working group is currently conducting 2 different projects. The first, to situate the importance of data to AI development and identify specific data sets that could be worthy of national support or international collaboration. And the second, to lay the foundations for future projects, including by defining of the most relevant terms, outlining existing data governance frameworks, and developing a roadmap for further discussions. On December 3rd to 4th of this year, Canada will be virtually hosting GPA's inaugural plenary as part of the GPA Montreal Summit 2020, where over 200 leading AI experts will discuss the initial findings from GPA's working groups. We are eager to see their progress on projects that aim to bridge the gap between theory and practice in key areas of interest. And our hope is that the work of the Data Governance Working Group can help shape our own domestic efforts in this area. For example, the Government of Canada hosts an AI policy community of practice made up of analysts with more than 20 federal departments exploring various topics linked to AI, including a possible framework for data sharing. Through a dedicated group on data trusts, the community of practice is exploring potential use cases to help inform an approach to data trust framework. And so, maybe just in closing, exploring the application of big data to agriculture and other key economic sectors will help unlock pathways to long-term innovation-driven economic growth that will assist economic recovery and resilience in both of our countries. And I would just say, I can't say enough how important it is that we get these use cases and these pilots in data trusts right in the depersonalized space, because they're foundational to growing the trust and capacity to continue that effort in the personalized information space, where obviously sometimes the considerations and the stakes are seen as much higher. So collaboration on data governance and AI between our respective governments, firms, universities, and research institutions is increasingly important as we work towards building a better post-pandemic future. And so with that, I'm very open to questions, and I'd like to thank everyone in attendance and reiterate my thanks to those who've made this series of workshops possible. So back over to you, Bill.
Thank you so much, Mark. And that's a great way to set the context on Canada's priorities and how it intersects with the global environment and the international efforts that are being undertaken. Certainly would welcome questions into the chat. And maybe just to set the frame, we can also just invite Dr. Kamakoti to offer some remarks. And as you think through some questions, we can have a bit more of an interactive conversation after Dr. Kamakoti's presentation. Dr. Kamakoti, maybe over to you now.
So Bill, I'll make my presentation. So what I did is sort of trying to define what we have learned over the last 2 days and today. I thought we could actually try and start defining what is agriculture data, what is the what is the personal and non-personal aspects of this agriculture data, and looking forward, what is a sort of a framework that is be of use generally to the world and specifically in the context of Indo-Canada relationship. I also have Dr. Vijay Kumar, who's joined with me today. So I'd like to first take this opportunity and sort of summarize the understanding of what is agriculture data, and then what are the technologies forward and how we can start a meaningful collaboration. And that is what I thought we would cover in the next 20 minutes, and then we'll open up for questions. So I'll make the initial presentation, then I'll request Dr. Vijay Kumar to make his observation, then we can open up for questions. So this is the overall framework. I'm just sharing my screen. So, so the data sharing framework for agricultural applications, this is very important because we need to understand the data, find out its purpose, the type of uses that it is going to put up, what would be the commercial value of this data, what would be the data that need to be shared, what are the conditions and what are the purpose of usage of this data. I think we need to get a broad definition. And I think that one of the biggest thing that we could get out of our collaboration is to understand this aspect and try to get full non-ambiguous definitions for many of the terms that I'm going to present here. Now, The first thing is understanding the why and what of agriculture data. What we are talking of digital agriculture and smart farming today, essentially we are integrating the farm to food value chain, and this essentially involves many digital tools that will be used to collect, store, analyze information that we keep collecting along this value chain. And we are looking at smart farming or precision agriculture, the way we put it here, is basically a manifestation of this digital agriculture domain, where we have certain agriculture technology and we want to enhance its effectivity or enhance its effective usage by feeding in certain inputs that we infer out of collection of large data in the past, and make certain enhancements to this whole farming methodology by doing this digital intervention. So essentially what we want to achieve from this, we want to increase the yield, we want to control the irrigation, we want to do proper harvesting, monitor soil health, prevent diseases, and then the whole lot of things of how to take this from the field to the market and do certain marketing strategies. All these things need a stack. It is not independent, that each one cannot be an independent entity, but there is a strong relationship from the farm to the market. And so this essentially means what we call as this entire automated mechanism. We need what we call as the KTFF, know the farmer and his farm, and or any personal or digital entities in the entire farm to food value chain can be deemed agricultural data. So unless we get a holistic approach in defining this agricultural data, we may not be having any meaningful solution. And so one of the prime orientation that we both as Indo-Canada can start looking at is to have a very clear definition of this agricultural data right from the farm to it reaches the consumer, and it transforms itself into a food. So that is one major effort that we need to take in this direction. Farmers, they have been collecting and using information about agriculture since the beginning of agriculture. As you saw Dr. Kanchan's presentation, the Panchang, which is now very effectively used by the Tech Mahindra team, and of course lot that you are seeing from the TCS presentation today. Now the main issue now is that when we want to make the farming sector essentially data oriented, we need to handle this exponentially growing size of data, not only in terms of volume, but there is a lot of velocity in this data collected. So the amount of data that flows per day is going to be quite humongous, even if you take one district or a couple of districts in India. And the quality of this real-time information obtained at the farm level and the technology actually used to collect, store, use, manage, share, process, and communicate data immensely matter here. So any data that we collect, process, store, share in the above framework must be classified as non-personal or anonymized. And how do we share this data? That is going to be a major crucial decision. So what are the type of data? How do we define that? And then how do we basically, define its use and classify it as personal or non-personal? This entire whole exercise on agricultural data need to be taken and understood very nicely. Now, what could be this data from a semantics point of view? It can be data about farmers, it can be data about a farm, it can be data about farming to production, production to business, business to business, or production to consumer, or business to consumer, several solutions. And this can also be, these data that are generated by humans or machine. It can be a machine to machine generated data, which can be stored, processed, etc. So at this point, the entire data flow architecture has to be completely conceived of, and we need to have proper privacy preserving mechanisms and compatibility of all these systems that matter, because a very complex system. I'm going to end this presentation with one complex network, and in this complex network you're going to have multiple types of data generated and used, and every data will have its own classification, and privacy issues can come there, sharing rights can be there, and so all these things has to be addressed. So what I did is that I just went through this whole exercise and thought, what are the things that matter the most? So these are the things that matter the most: the stage and nature of data, how data is collected, who owns that data, what data is owned, and which form it is owned, what are the access mechanisms of the data owned, who has the right to ownership, who has the right to process that data, what are the private data, collective data, and public data. So if you look at farm, there are some individual data about a farm. There are collective things that you get in say one locality of the farm, and then there are data that are public, like environmental data, etc. And then the data forms, the data states, all these things matter most, and everything needs to be addressed in a single in a very integrated and unambiguous way. Now, there are some definitions of personal data. I just want to talk about the PDP bill from India. Personal data essentially means data about or relating to a natural person who is directly or indirectly identifiable, having regard to any characteristics, trait, attribute, or any other feature of the identity of such natural persons, whether online or offline, and it goes. We also have a definition of a non-personal data. This is by a Chris Gopalakrishnan committee, which essentially says that when the data is not personal data as defined under the PDP bill, or the data is without any personally identifiable information, it is considered non-personal data. So there could be, again, this non-personal data essentially is classified as public non-personal data, community non-personal data, and private non-personal data. So the key question is, in the framework of agriculture data, what is the PII? What is the personally identifiable information? How to identify or define PII, and how to comply with this? So given this two broad classification of data as personal and non-personal, and now we have to fit in agriculture in this framework and evaluate. And I think that is also going to be a major task for us going forward. And of course, at the end of this story, the data ownership, the data anonymization and privacy preserving techniques, and the consent mechanisms, consent not only to use the data, but to collect, store, transmit, and process also matters. And they should meaningfully prevent the risk of re-identification, etc. So it does actually become necessary to categorize all these data. Now, in the context of agriculture, I basically come out with two types of data. One can be a machine inferred data, and another can be an anonymous personal data. And so I just give some thought process on what could be machine inferred data. Something that is collected, generated, processed, stored, transformed through digital machines and instruments. For example, we have GPS, we have sensors and drones. These are all machine inferred data. And there can be data generated by software through predictive models based on weather, soil health, irrigation, crop health, etc. And there could also be data analyzed from historical and contemporary data where machine inferred data is used. Right? So these are all some of the machine inferred data. When we come to the anonymized personal data, we have data about land holdings, contracts, banking and financial transactions, land produce, pricing, profit, logistics, consumption pattern, etc. And there can also be data generated by software through predictive models based on Turbo. And the data analyzed from historical and contemporary data where anonymized personal data is used. So these are some two different forms of data, but then they can come out from different sources in the agriculture stack. So so to sum up, these are some of the basic building technologies that we need to look at very carefully when we want to build an agricultural data stack and agricultural data definition and usage and a data trust that we have been talking of. Like we need to think of processing data for a purpose other than that for which it was initially collected. So this is one very important. So when we collect data specifically in the area of agriculture, and it's a growing field, we may not have a comprehensive definition of what we will be using it for. So today I collect data, but I may be using for N. So this is a very important thing that we need to keep in mind. And the GDPR actually talks about consent and a compatibility assessment, which comes under the category of principle of purpose limitation. So, and also even when personal data is anonymized, there are certain data rights and privacy that matter when we process that anonymized personal data. So we need to look at this principle of purpose limitation and see that what would be a consent that we need to get from the farmer or whoever is generating the data on the what are the different ways by which it will be used in the future, and these compatibility check actually has to be done. So there is a consent versus compatibility assessment that needs to be done here. And since we are talking of certain privacy preserving, we need to look at certain privacy preserving machine learning techniques like federated learning, differential privacy, and homomorphic encryption. These are some of the real machine learning techniques that need to come up here. And so we should also answer questions like, do we have a different mechanism than this where we can mix the consent and compatibility assessment? And can we have temporal consent coupled with contextual compatibility assessment? So how are we going to define this language? So these are all some very important things that are yet to be defined, all right? And then we need to start looking at it from a very clear perspective. So one of the exercises that I propose as an outcome of this workshop is that the team from India and Pravartak and all, we can form a larger team, and from Canada could address these basic data sharing mechanisms, the data generation mechanism, the data classification mechanism, and come out with clear categorization of data. Once we categorize this data, then the rules of the GDPR and the rules of the data policies of the respective countries can be applied on them, and then the whole process becomes much more smoother. So this is where the whole whatever I could guess out of the last 2.5 days, last 2.5 sessions, what I could get out of this is what I thought we can summarize. And given this, one of the initiative is, we call it the Rasa. Rasa in Sanskrit means to the material world it is juice, for a philosophical world it is eternal bliss. So the regenerative agriculture stack architecture, and this is what I feel that we can start as an Indo-Canada collaboration. And what it involves is this: there is the farm, there is the food. Now for the farmer, he needs support. He needs to find out what should he grow, when should he grow, and how should he grow. The entire mechanism. So what should he grow? One crop, two crop, multiple crops, as Dr. Vijay Kumar presented in his one. And when, what is the season, and what are the different steps, and when he grows, what are the fertilizers, or what are the other farming techniques that he needs to use. So all these things he needs guidance, and when that guidance can be digitally given, then it becomes the subject matter of precision agriculture or data-driven agriculture. So what we have here, we have accurate sensing of current field parameters. I just borrow it from the TCS presentation, the earth parameters, right? The soil health, and many things that you infer through sensors. And we saw many presentations in this direction, even in this workshop. And then we have accurate sensing and collection of current environmental parameters, what I call as ACT, right? All your meteorological data, atmospheric data, etc. The wind direction, for example, are all important. So my farmer in the village actually sees the wind velocity, the direction with which it comes in a particular part of the day, and he says that whether there will be rain in the next 2 days. So these are all some very, very interesting observations we could see in our farmlands deep in the rural India, right? So accurate sensing and collection of current environmental parameters, and these two are going to be on a continual basis, and this will form the big database or the data trust that we are going to create. And so this is going to be part of that. And what this will feed, these parameters will actually feed is a data-driven models, including AML statistical models. So many presentations we saw over the period of time, even in this workshop in the last 2 days, which are the data-driven models. And these data-driven model, along with the current field parameter and current environmental parameter, will drive a data-driven decision and advisory support system, which will, the other part, there is also a market demand, which comes from the market, and then all these things will drive a decision and advisory support system, which will help the farmer to answer these three fundamental questions: what to grow, when to grow, and how to grow. Once this is grown, then it has to go through the storage. Storage is going to be a very important factor. We are seeing that in India. So we need to get a lot more of the storage mechanisms in place, where the produce is kept under proper conditions. Every type of rice, I can tell you there are 350 varieties of rice in India now in practice in South India, Andhra, Kerala, Karnataka, Tamil Nadu put together, and yeah, I'll just mention. And this will be and every rice variety has a storage requirement, and then there's a procurement, then there's a quality assurance that we need to do, and then there is a marketing. And then we need to have a digital marketplace, which the Tatas actually made today. The TCS presentation did hint on that. And then finally it goes to the food. So this is the overall stack. And then what are the things? There are 6 important needs here: sensing technologies, varieties of sensing technologies, communication technologies. We looked at some technologies in the first day, and then large data analytics that is needed, and then AML statistical prediction tool, farm to food safe delivery network, and a digital platform for producer consumer relationship management. All these 6 are extremely important to actually get this stack in full place. And I strongly believe that this workshop will forge a very nice interaction between India and Canada to address all these 6 fields, and we could do something very constructive in taking this to a nice stage of implementation. With this, I open up for questions. I thank the Canadian Supercluster for this wonderful opportunity, and now I open up for questions. Thank you.
Thank you very much, Dr. Kamakoti. I believe we do have some questions along the way, and I think this will help to bridge to the next section as well to talk about the path forward. But as Kevin and as Mark on the Canadian side have both alluded to, there are quite a number of standardization efforts that are underway. Perhaps the question is how do we see the timelines proceeding, and how can we characterize some of the efforts, Dr. Kamakoti, that you were just sharing right now?
Okay, so before I proceed to answer this question, I would like Dr. Vijay Kumar to make a small observation, and then I will take up this question. Dr. Vijay Kumar.
Thank you, Dr. Kamakoti. I'm audible?
Yes, you are.
Okay. I think there's very little for me to say after your excellent presentation, the way you have analyzed the RASA model. So, but I just want to bring out certain, issues on ground. We have, very large number of farmers who are semi-literate, the small holdings, small and marginal farmers, 86% of farmers, have area less than 2 hectares. That is the reality. So it's very important to see the knowledge knowledge dissemination dimension in terms of the kind of support they require. So it has to be a human mediated dissemination. So I think it's a very challenging process of providing support to such large number of farmers. And I see a great opportunity in this RASA, in building capacities of farmers, disseminating innovations, developing virtual training academies for millions of farmers. And also, as we are seeing, the regenerative agriculture model is climate change resilient, is basically overturning many conventional paradigms, because currently the entire paradigm is still around, synthetic chemical based agriculture. So we also need to have evidence, and that's where I see a very important role for digital technologies on how do we establish that regenerative agriculture in the Indian context is not only benefiting farmers' livelihoods, but is also ensuring that soil health is improving, biodiversity is improving, quality of food produced is much better. For instance, can consumers know that the food grains or fruits, vegetables that they are consuming from regenerative agriculture is superior in terms of nutritive values? So we also see how education of the consumers is an essential part. So as I mentioned, till now, agriculture currently is one of the major problems in climate change. Can the same agriculture through regenerative agriculture be a solution to climate change, to food security, and to health of the society at large? So I really, look forward to working with you and working with a group very closely to find answers to the various problems we have. And finally, how do we take this to all our 160 million farmers and farm workers and achieve the goal of the Government of India, especially the Honorable Prime Minister, of doubling farmers' net incomes? Thank you, Dr. Kamakoti.
Thank you, sir. And so let us take for the timelines. I think one of the things that we feel that we need to do as a part of this collaboration is we identify we classify the data as farm that we collect from the farm, we collect from the marketing part on the different stakeholders, and we need to basically define this data, define the purpose of this data, define the from the GDPR, our PDP, both countries will have personalized, non-personalized definition. From the definitions of this data, go and categorize it as what is personal and what is non-personal, and assign the rights. So every data we need to have a capability and assignment of right and ownership. Once these are all finalized, I think that is an exercise that we need to take and where different stakeholders need to participate. Once an exercise of that is done, then any tool that is built, we can go and see the owner of the tool essentially means are the owners of the different data that has contributed to the building of the tool. And there we need to, either there is a consent mechanism for somebody to use that for building the tool. Do they see a commercial value there or not? And these are some things that need to be succinctly addressed. And so we look at the timeline, it's going to be an evolving thing. I don't think we can finish it off, say, in 1 month or 2 months, but this is going to be an evolving field. At least, when the definitions of from the GDPR and the individual countries, when the definition of personal and non-personal data is freezed, I think we can start this exercise. And for every equipment that is introduced into the farming sector, for every methodology that or any sensing mechanism, we need to classify that, and that becomes extremely important for building the RASA stack. So that is my overall answer to the question by Tripower Technologies.
Thank you, Professor. Maybe I can ask Mark for his views as well.
You bet, just coming off mute. Thanks, Bill. I mean, I guess in some ways, there's a number of ways to come at this question. I mean, I think that Professor Kamakoti has obviously gotten at it at the very precise level of the kinds of standardization for data sharing on a project-specific basis in some ways. I guess when I come at this question, I start from the macro, which is the kind of interoperability of data sharing at its highest levels, which really starts with the ability to share data between economic blocks or regions. To that end, I mean, I guess Canada is very open on pursuing interoperability in a number of different kind of tracks. So one, obviously, we were one of the first countries outside of the EC to receive adequacy status under the previous privacy regime in the European Union, and are on the track towards continuing our adequacy status under the GDPR. And so we see that as a core building block for the kind of interoperability and data sharing that's sort of pivotal. And the modernization of our privacy legislation on the private sector side, which we're in the midst of, we see as critical to meeting that standard. We are, however, also members of the APAC cross-border data rules, which has a broader kind of set of constituents to potentially also facilitate a B2B mechanism and broader efforts to allow for data sharing between regimes. And then obviously, hardwired into the proposal that we put forward as part of the modernization of our privacy standard, of our privacy regime, is the capacity for actual standard certifications and codes to actually have statutory relevance and consideration within the privacy regime. And in the conceptual framework we laid out for our privacy modernization, we saw these sort of framework laws as a foundational effort that have general application, but that then could be built upon with activity-specific regulatory regimes or standard certifications and codes in zones like precision agriculture, in zones like open banking, in zones like smart cities, where you can establish the certification standards, codes, or activity-based regulatory regimes that are actually going to allow for use cases to build out and that get you further than a law of general application would allow. So the timelines for these, obviously, there's quite a bit of work underway, and I think you'll see more from us on the privacy side very soon. But I guess it depends in some ways on which aspect of interoperability or standardization we're looking at, because I kind of characterize it across a number of domains.
And maybe this is the time where we can start to look forward on a few things. And Professor, I know that in our conversations, this might be the opportunity to do a little bit of a wrap up on what we've seen today and some steps that we might take going forward. So maybe I can turn it back to you again.
Thank you. I think, so as a wrap up, I think one of the things that we propose from the India side is to take up the RASA, the regenerative agriculture stack architecture, and we basically start building the stack. The syntax of the stacks come from the different electronics, mechanical, and the computer science interventions that are going to, and metallurgy and many fields that I have seen here. But the semantics of the stack essentially comes from the different processes that we need to build across that. And I think these two are going to be extremely important. And the farming techniques that we have been using are going to dictate the semantics of the stack. My take on this is that we will start working on the RASA as a joint Indo-Canadian initiative and learn the best practices from both and see which technologies can be used to build this stack, and then make it as a globally a very high quality stack. I think that is, I'm very sure that given the expertise that we have displayed in the last 3 days of this workshop, I'm sure we will be in a very competitive position to do that. And this is my comments. And I now invite Mr. Stewart to give his views.
Well, thank you very much, Dr. Kamakoti, and thanks to all who have presented today. And over the last 3 sessions of this workshop, I have to say the level and areas of cooperation and collaboration are really quite large. And I have to think back to when I first traveled to India with Sheldon Levy, who at the time was the president of NextAI. And really, Sheldon is in some ways the godfather of this concept of how do we work together between Canada and India, because from a Canadian perspective, we have some really good technologies and great scientists. And in terms of machine learning, I think it's recognized globally that Canada has some real leadership. One of our challenges, of course, is that in terms of access to data, and machine learning requires data for it to improve. We don't have the same resources that India has, and that I think is really the defining reason for getting us going in this direction and how to build a collaboration. As High Commissioner, at the time I was High Commissioner, our single largest export was pulses. And it's one thing to sell pulses in a commodity market, but I always was saying at the time that really it's agri-tech and that's going to define the future of our relationship. And this really, in my mind, has been the ultimate way of demonstrating what I thought was really an excellent area for collaboration. And I think RASA, coming forward with the regenerative agricultural stack, I think will be a true area for collaboration between the 2 countries. And this last session, I think, was incredibly important, because for us to be able to work together around data, we need some sort of governance structure that makes sense. And ultimately, we may get to a level at the multilateral level on governance structures, but why not try and do something at the bilateral level? And I think this was the purpose of this session today, but also at the end of this conversation, it's really what's going to drive the success of the Canada-India relationship in the area of data. So again, from my own perspective, thanks to Bill, thanks to Dr. Kamakoti, and on my own team, I want to thank Christine and Angela, who's based in India, for really helping pull all this together. And so again, this is just the first step. I look forward to the next one. So thank you. So now I'll turn it back to you, Dr. Kamakoti, for your final thoughts.
Yes. I must thank Mr. Stewart, Mr. Bill, and all the team from the Canadian side who have been working very closely and just making this workshop, minute-to-minute program has been arrived at. And we had meticulously organized, and we had speaker calls, speaker test. It is a very interesting and very nice case study of how to organize and an effective, virtual event like this. And we have kept the interest also alive. I actually see still we have, 40 people who have logged in, and I'm sure we have made this workshop very interesting also. I thank the entire team for the effort from the Canadian side. From the Indian side, I thank all my colleagues at IIT Madras and Pravartak, and also all the speakers who had come from the different industries and institutions to participate in this workshop. I'm sure that together we'll form a very big consortium and work towards making our farmers' life a very, very interesting one. Ultimately, in Indian philosophy, in Indian scriptures, we say agriculture is the only field where there is growth. For example, if you take jewels, right, you take gold, they cut it, everything diminishes, right? But agriculture is the only field where you put one grain and you get 100 grains. So let us. So that's why agriculture is given the, the most important, given the maximum importance in the among the professions and among the the different sectors, right? So I'm sure this initiative will grow like agriculture, and then we'll do a great job in this. And it's a very good first step, and we have taken the right first step, and I'm sure we will take it to completion. So though we are celebrating the initial inauguration, I'm sure we are very keen to celebrate certain success in terms of products, and ultimately a farmer coming and saying it is useful. I think we'll wait for that day and celebrate more that day. With this, I hand it over to Mr. Bill for next time.
Thank you, Professor. And I couldn't agree more about the partnerships that we have been able to initiate through this. I also want to recognize the team led by our colleagues at Terra Mera and the Precision Agriculture Project, which was really the basis for a lot of the conversations on this series of workshops. I think it was quite appropriate that we started the talk today with a keynote from our colleagues from TCS, because the title of it, of Harnessing Power of Sky and Earth, really does captivate and capture the essence of how we're closing today. On the one hand, we have the work effort of what Mark, Shan, and Keith were describing on the bigger standards piece, and the work that's being done across all sectors and international collaboration. But I think when we get down to the earth level, agriculture and the use cases around the precision agriculture piece is a very, very strong potential starting point for seeing these things actually be pursued. And at the Supercluster, our work effort is often characterized by initiating collaborations which can be done in a very discrete and very specific and very deliberate way. And I think the path to success really is a combination of earth and sky. And I take solace in the fact that we're calling this rasa, because I think we are all seeking eternal bliss. So with that, I want to thank everyone for joining us today. And thank you especially to our colleagues in India who have stayed up very late for this.